All right, folks, let's get started. So in this video, we're going to be starting an entirely new topic. So we're going to be talking about sorting. Here, right, we're going to talk about what we call elementary sorts. Later on in the course, we'll talk about all kind of, we'll talk about several other ways to do it. Right now, we're going to kind of review some that maybe are, should be a little bit familiar to you, but then talk about them in more detail. All right, so sorting. So what is sorting useful for? Well, tons of stuff, right? So sorting, right, hopefully you guys already know what it means when I say sort, right? So the idea is I have some collection of things, right? Some collection of elements, and I want to order them somehow, right? So maybe I have like a list of names, and I want to order them alphabetically, or a list of numbers, and I'll put them in increasing order, right? That's basically the idea of sorting, right? I have some collection of things that has some sort of order expressed on it, and I want to put them into that order, right? When I say order, somehow I mean that I can like look at two elements and compare them and see that one maybe comes before or after another one, right? That's what it means to have an order on it. So yeah. So there's all sorts of uses for us, right? So you can think of, you're sorting, a list of names, right? Maybe it's my class roster and I need to alphabetize it. So you have other examples here, right? Ordering objects on a screen. So think about, when your operating system or, some piece of software needs to draw something on your screen, there's usually a lot of different elements there, and it has to figure out what does it draw, first and then last, right? Because like you imagine you can draw something, right, and then you draw something on top of it, right? So, and it's only those kind of those final things you draw that you actually see, right? It's like if you picture you're an operating system, right? You have the desktop and then screen over it. Well, you need to basically display the desktop first and then draw a screen over it, right? The active thing that the user is looking at, right? So you need to somehow order the things that are to be displayed. That way, that when you draw your picture, you get things that are to be visible in the proper order. Let's see other things. Executing processes, right? So it's like, well, hey, I have a bunch of programs running on my computer. All these maybe have some sort of different priority associated with them. We need to figure out who should be able to run next. Because we only have a finite amount of CPU, we need to determine what is going to be the next thing to run. So there's plenty of other examples of sorting as well. Those are three kind of that are, well, the bottom two may become, the middle two may become a little bit from another class I teach is operating systems. First one's very generic. Hopefully yourself, right, you can kind of imagine some other purposes for sorting, right? Sorting is a very useful tool, right? It's basically a way to give us some sort of a structure, right? Because normally I start with some pool of elements, right? So it's like I have out of the box this pool of elements, and I really don't know what is in here, right? I could have all these numbers, right? Blah, blah, blah. I don't really know what's in there, and it's just kind of this pool, and I don't know anything about it. The hope with the sorting, right, is that if I take this collection, right, of things, right, I can somehow produce that same collection of things, but all of a sudden there's a little bit more structure to it, right? All of a sudden I have them in a certain order, right? 2, 3, 4, 5. Right? This is maybe more useful to me, right, than just having them all in this big bucket, right, this big pool of things. So you can think about, for example, algorithms like binary search, right? So if I have a collection of elements, I want to figure out if something's in there, well, I can do a linear approach, right? I can go and I can look at each element in turn and try to figure out if there's a match, but that's a little bit expensive, right? That's over in time. So maybe a better approach, right, something like binary search, where it's like, well, oh, hey, I'm going to start in the middle, right, and then if I'm looking for something smaller than what I see, I'll go to the left. If I'm looking for something larger, I'll go to the right. If I have something like that, right? Well, if I want to do something like that, I need to have some sort of structure to my data, right? And specifically, right, I need to have it, sorted, right? If I don't have sorted data, there's no way for me to perform a binary search on it, right? I'll basically be, looking at my data, right, jumping around, but I end up jumping, to, the wrong place, right? Binary search basically is assuming the data is stored a certain way, so it gives us some assumptions about where is going to be the proper place in this, input, data to look for what I want to find. And it's only through that, that assumption that it's like, oh, they're going to be in this order, that I get anything out of it, right? Otherwise, I just get some sort of nonsense result. It's also useful when you're doing some sort of alignment or mapping, right? So let's say I have, two collections of things, right? And I want to see are they the same, right? Maybe I have two strings. I want to know do they both use the same letters? Well, sort each of them, right? It'll put the letters kind of in the same order in each of them, and so you can put them side by side and say, hey, how do these match up, right? Which letters does this one use? Which letters does this other one use? What is the alignment there? So that's another thing we can do. Another example here is this idea of decomposition. So somehow there's the idea where it's like, well, if I have a list of numbers, right? So here we have a list; they're all kind of the same. Other lists of numbers, right? Maybe when you sort them, you get something interesting. Like you see, oh, hey, there's 3, 4, 5, and then over here, 10, 11, 12. So it's like you have two different clusters. There's also the idea in there of something called like a natural break, where it's like, oh, hey, I can look at my stored data and I can see that between these 2 points, right, there's a big delta, right? So this is like, there's a difference of 5 there, versus these are different by, 1, 2, and then this is 1, 1, 1, right? So it's like those are two little clusters of things. So this is another way, right? There's another way basically we can learn about our data. We can learn that our data has, basically, subset A and subset B, right? That are basically, have a little bit in common, right? Their values are all kind of the same. So that's the other thing we get from sorting, right? If we have all our data, right, we go from basically this bucket or this pool over here with tons of stuff in there to know a little bit more about, what is that information, right? What do I have there, right? I can start to categorize it a little bit. All right. So moving forward, talk about the data itself. So we can have data that's either simple, right? And here maybe we can also think about the word like primitive, right? So if you're thinking about Java specifically, you have primitive types, right? You have integer, double, float, things like that. Well, those are all going to be simple types. Basically, it's something I can compare directly, right? So I have all these numbers here, and I can take 2 out, right? I can look at 7, I can look at 2, and I can query, is 7 greater than 2? And if I do this right, I get back true, because that's a true statement. It's something that I can look at directly, right, and know, how are they ordered. So not all data though is simple. We also have complex data, or sometimes they use the term compound data. This is something that's maybe a little bit more complicated. Here, right, we had no choice but to compare 7 and 2. But I was saying like a date, like let's say we have April 1st, 18 versus July 1st, 18. Well, what is the rule there that says we should compare what? Maybe intuitively we can say, oh, hey, we want to compare the month, but we also need to think about the day, the year. There's a little bit more to it. We have kind of 3 choices of numbers to look at. And so maybe in that case, you have a more complicated rule. Either case for us, right, we want to be able to treat it. Whether it's simple data, whether it's complex data, we should be able to sort an array that's map either of those with our algorithms that we want to look at. All right. So generally, right, we have this notion of a key. So a key basically is saying that whatever data I put into my array that I want to sort, there's going to be some way for me to look at that data and figure out, these 2 elements, what order they go in, right? There's some sort of a key that tells me their order. In this case, right, for the case of simple data, the key is basically the piece of data itself. So it's like 3, it's its own key, right? That's how I'm going to sort it. If I have something that's a date, right, maybe it's a little bit different, right? Maybe my key all of a sudden is my month instead, right? So basically what we're saying is there's a specific way to call out what it is, right? What is the part of the complex data type that we actually will compare when we want to sort them. I will call that the key. All right, so for now what we're going to do is basically assume that when we do kind of our algorithms and stuff like that, when we're trying to figure out how to sort data, we're going to have something called less. So less is going to be this little mini method over here. And the idea is I want to provide an easy way to encapsulate is v less than w. Now in Java, right, there's something called comparable, and we'll talk about it later. Well, the problem though with comparable is basically going to be that it's a little bit complicated, it's a little bit of syntax, blah, 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 blah. Let's make life easy for ourselves. Let's introduce this new method over here called less that does that very simple, the equivalent of an equality check to see whether 2 things are in order, right? And that's going to be kind of our basic building block. So whenever we want to go basically and do sorting, we're going to do sorting on some, pool of data, right? Typically going to be for us an array at this point in time, where everything, right, is something that has an order on it, right? And that's an order we can query using this less function, right? And then internally, right, when we get to the Java side of things, that less is going to be implemented by basically querying that comparable interface. All right, so this is a quick overview of kind of where we stand with sorting, right? So our goal here, right, in this section is really going to be looking at this problem, right, of, oh, I have this data and I want to sort it, and trying to figure out, what are the different things we can possibly do. We're going to look at 3 different algorithms. One's selection sort, insertion sort, and then finally shell sort. These are all going to be different mechanisms for solving this problem. We want to kind of start fleshing out our tool set with different ways we can solve this. So we're going to spend a little bit more time talking about sorting in general, and then we'll jump to talking about the first algorithm, which will be selection sort.